Hi, today I will explain a brief of quantum sampling. First of all, what is sampling? Sampling is a technique to select a subset of a small population from large population and allows us to estimate the characteristic of the whole population. What is quantum sampling? Here are many following questions. How does it work? Does it work like a classic sampling and so on? Let's discuss it briefly today. First of all, we define quantum state as follows. Cat xj equals a unitary operator u times cat b. U is an evolution unitary operator that acts on cat b. Cat b is one of the bases in Hilbert space. For example, in the two-dimensional Hilbert space, cat b can be either cat 0, cat 1, or both. Then the unitary operator u evolves the cat b to a new quantum state, cat xj, which is basically rotated and jumped from the initial basis by the operator. Then we can define an honest quantum state, cat x0, that we want to find among the quantum population. Cat x0 is the state that Hadamard operator acts on cat 0. The Hadamard operator is a beam splitter of a photon, which splits equally the original photon to the superposition of two states. We can visualize the cat x0 like this ball. Actually, this is the same as the cat plus state. Then we ask ourselves, how many of these honest quantum states are in the basket? There is a big n number of quantum states, and we assume the big N is too large to count all. The previous question is equivalent to what is the noise of these quantum states in the basket? Should we choose and measure them all to get the answer? I don't think that is a good approach because the big N is metered. So we'd better select some small subset from the quantum population. The number of small subset is little n. So we sample little m number of small quantum population. Then we measure the m number of samples to get the outcomes. Each measurement outcome tells the quantum state of the small samples is whether honest or dishonest. Through the measurement outcomes, we can know noise in the small quantum population. What is noise? The noise state is if a measurement outcome Q sub j is not equal to 0. 0 is the measurement outcome of the honest quantum state cat x 0. In our example, Q1 is not equal to 0, Q2 is 0, Qm minus 1 is 0, Qm is 0. By counting the number of outcomes that are not 0 and dividing by the number of small samples, m, we can compute the noise rate of the small quantum population. We call this WQT is relative Hamming weight that tells the noise rate. Then we define the noise rate of the n number of remaining quantum population as a WQ bar T, that is the relative Hamming weight of measurement outcomes of the n number of quantum states. In classic sampling, we can estimate the noise rate of the remaining quantum population by the above sample. But how about quantum sampling? Can it estimate the characteristic of the remaining quantum population? It's hard to say. Because unlike the classic population, quantum state in the quantum population are maybe intertwined with each other. Or more likely, the measurements the small population cause a change of the remaining quantum population. So quantum sampling is not trivial question, but it is hard to formalize them between the small sample and the remaining quantum population. In the following videos, we will look at how the measurement changed the remaining quantum state and the relation between them. Thank you for watching. God bless you.